Japanese knotweed is an invasive plant native to Japan and East Asia. According to a team of former Penn State researchers and educators, it was introduced, quote, in the late 1800s as an ornamental into stabilized stream banks. This has caused Japanese knotweed, scientific name Falopia japonica, to take over the forests and stream banks and roadsides of North America, including Connecticut. Thankfully, for conservationists and scientists across North America, Japanese knotweed is pretty easy to identify. As you can see in this diagram over here, it has oval heart-shaped leaves that grow in an alternate pattern. In addition to that, the stems are very bamboo-like and are segmented up and down the stems. So it's pretty easy to see, especially in Connecticut's landscape. We don't have a lot of bamboo-like plants like that. In addition to the segments, in the summer when it flowers, it gets these ivory white flowers along a shoot or like a stem of some sort, and it will curve out like that, and the flowers will be popping off along that. And then it also grows in almost a zigzag, straight up, but then the leaves pop out in almost a zigzag pattern. It's also important to be wary of the root system and rhizomes that grow underneath, which causes the Japanese knotweed to grow up in patches. It doesn't really grow up like trees where there's one over here and one over there and one over here. It's very much a patch or a shrub of Japanese knotweed. Japanese knotweed is bad, but how bad? Well, first off, it grows and outcompetes natural plants due to its ability to spread by its roots, more specifically to spread by its rhizome. A rhizome is a long horizontal growing root that can spread out new versions of the plant. A knotweed can spread by these rhizomes if it's disturbed in any way. For example, if you were digging a foundation and dug into a Japanese knotweed section and cut its rhizome, a new version of the plant could grow there where you cut it and wherever you dump the rest of the rhizome, which helps it grow not just fast, but far. This means the knotweed can spread by like wildfire, quickly outcompeting and overtaking the habitat where a variety of native plants could grow. This both directly kills the native plants as it could choke them out and results in a loss of biodiversity in the area. The Invasive Species Center, a nonprofit based in Ontario, has collected information on the invasives of Canada, which also happen to be most, if not all, of the invasives in the northern United States. On their page about Japanese knotweed, they mention that the fruit is a winged fruit, meaning that it spreads by air or water. It just floats. It doesn't have to get eaten by a bird or stick onto a mammal or get eaten by another animal. It can just spread. This doesn't provide much food for native animals and helps it spread even further than it would if it had to be dropped in a certain area or if it had to be eaten and spread that way. Japanese knotweed can damage buildings too, as it can grow through cracks in concrete and it grows extremely aggressively. It can go really fast too, as fast as 8 centimeters per day or 1 meter in 3 weeks. The yearly cycle of knotweed is as you can see in this diagram up here. It starts in spring, and it's these little tiny shoots where it'll first shoot up from the rhizome or from wherever a seed was, and then by the summer it'll have grown a lot, probably 2 to 3 meters, and will flower for the summer. And then in the autumn it dies out just as any other deciduous plant would. And then in the winter, on this diagram it says that it turns into white stalks, but as you'll see later in it, it turns into like a black stalk here. I almost wonder if the winter over in England, where this diagram was from, it's from the UK government, it just does a different thing than it does over here, because they might have just different winters. Now that you know the negative impacts of Japanese knotweed, what should grow in its place? Well, because of its herbaceous and shrubby nature, it can grow both where a lot smaller, more delicate plants could grow, and then it can stay there and block out hardier, woodier plants like trees and shrubs. The U.S. Department of Transportation has a whole website where they have huge lists of native plants that grow along roadsides, where Japanese knotweed is often found. Notable species I found on this list include blueberry, mountain laurel, birches, maples, white and red cedar, and eastern hemlock. My pick for an ideal replacement species that is native to Connecticut is mountain laurel. Mountain laurel is not only the state's official flower, but it also has many beneficial environmental services. To understand one of these services that mountain laurel can provide to the environment, we first have to talk about soil microorganisms. specifically mycorrhizal fungi, and how they're important. Mycorrhizal fungi are fungi that have a symbiotic relationship with plant life, most notably trees and shrubs. According to Eli Ward, a PhD candidate of Yale, quote, some types of mycorrhizal fungi actively mine soil nutrients from organic matter through decomposition, whereas others increase uptake of plant available nutrients by functioning as an extension of the root system, end quote. These are both very valuable not just for the organisms involved, but also for the environment and soil health as a whole. This is especially important in New England forests, where there's a lot of dead plant material such as leaf litter, broken branches, and downed trees, so decomposition is a vital task. Mountain laurel, scientific name Kallima latifolia, and other shrubs in the Ericaceae family have a specific interaction with a unique kind of mycorrhizal fungi called ericoid mycorrhizal fungi. This fungi, Ward and his team found, quote, had a strong positive influence on soil carbon and nitrogen and were associated with a buildup of organic matter. This is a great thing for soil health and is halted by the encroachment of Japanese knotweed into native shrubbery habitat. Beyond just the environmental health aspect of mountain laurel, it is also a beautiful plant. As you can see in this picture, it has a beautiful pale pink flower that I would argue is more beautiful and more pretty than the white ivory flowers of the Japanese knotweed. Now that you know what plants we could possibly replace knotweed with, it is vital that we talk about how to get rid of it, especially taking into consideration its roots and rhizomes and the fact that it spreads so quickly. The Simsbury Land Trust created a pamphlet with how to combat and maintain a variety of invasive plants. One of the plants featured in the guide was Japanese knotweed. This is what I used when I maintained it on one of the properties when working with the Northwoods Land Conservancy of Heartland and Park Hampstead. In the book, it recommends cutting it 3 times per year in late May to early June, in late July to early August, and in late September to October. It also says that you could use herbicides by painting it on the actual plant itself or by injecting it directly into the plant. However, Northwoods Land Conservancy has a no herbicide policy, so we did not do that. We did just the cutting. Now I'll show you footage from 3 different sites, one where there isn't any knotweed yet, one where the knotweed has gone unmaintained, and one where I went and helped maintain it with the Northwoods Land Conservancy. And you can just see the effect that this plant has on the ecosystem. So here we have a habitat that the Japanese knotweed has not yet invaded. This is a roadside and streamside habitat, so it's good at showing both places that the knotweed is most commonly found. And as you can see, there's quite a diversity of different plants here. There's mountain laurel, which, I mean, you know how much I like mountain laurel as a replacement for Japanese knotweed, as well as some oak trees and some hemlock and some pine and um, maple trees as well. You can see it's a variety of different plants, and the biodiversity is huge here. There's a lot of different birch trees, and there's some grasses and flowers that you can see have died out for the fall. But I know from personal experience that it gets very green here. Like it will grow in a lot. The state will have to come by and mow it more than once a month because of just how much stuff grows in this area. And again, you can see the mountain laurel growing in such plentiful amounts that you just know like it's a good indicator of the soil health if it's interacting with that fungi that I discussed earlier. And then here's just another roadside right near there where you see the state mows it enough that there's nothing growing, but there also isn't any knotweed growing. So it's like a double-edged sword of at least there's no invasives. And then right here is a pretty dense thicket of Japanese knotweed that I found when I was driving to work actually. And you can see it hasn't been treated at all. The knotweed's probably 2 to 3 meters high. And I would say it took me, I think, 2 minutes to walk around the whole perimeter of it. So it's a pretty big stand of the plant. You can see it as evidence of it flowering with the orange of what used to be like the white or ivory flowers are now orange because they've died out. Um, and you can see just how far it goes and how thick it is. There's no room for anything else to grow in it. It's just knotweed. Um, and as you know, like the biodiversity here is just so bad. It's just so uniform of just the knotweed and nothing else. There's no plants that can go anywhere. in this area because of just how much it's taken over. And then here is the area that I treated, that I cut. So up along the entire guardrail up the hill, there was knotweed, and it was pretty tall. It was probably like a meter or two tall. And now you can see it's just these little black shoots, because it's died out for the winter and they haven't flowered out. And I only cut this in July. I did not do the 3 cuts because I got busy and I forgot. But even just my third of amount of effort as I should have put such a huge dent in this area of knotweed and of this population. Um, that being said, as you can see, even though it's the fall, it's not dead all the way. It's just dormant. Here's just a closer look at more of the knotweed, like a specific individual. And as you can see, it's still green on the bottom. And I'll break it, and you can see the inside's still wet. It's still green. It's still alive. Sadly, it's not gone yet. It's not dead.